For our last topic in section 5.3, we want to talk about at least probabilities. In particular, we're interested in at least one, right? What's the probability of at least 1/5? What's the probability of having at least one boy when you have 3 children? And this particular probability will crop up for us quite a bit in chapter 5 and 6. So we want to be able to find them. And now we have a little definition box here that tells you what you want to do, and that's to find the probability of 0 somethings and subtract it from 1. So if you want the probability of at least one, star, find the probability of no stars and take it away from 1. All right, so let me see if I can explain that in a way that has context. So we're going to look at the roulette wheel yet again. So we're going to spin the wheel 2 times in a row. So we're going to spin it twice. And you're going to place a 7-10 line bet for both spins. Remember that Appendix B tells us what a line bet is, and I'm going to go put a little chip icon where that is. Okay, so the 7-10 line bet means that you put your chip right here on the line between 7 and 10. That means you're betting on all 6 of those numbers on that line. Seems pretty straightforward. So, but if you're going to let the bet ride, that's what it means, more or less. So you're going to let the chip sit there. So you're going to say 7 to 10, and then win or lose, you're going to place the chip there again and bet again. So there are a couple possible outcomes. You could win on both spins. It is possible that the ball lands on one of these 6 numbers both times. Then you could win on the first spin, but lose on the second spin. Conversely, you could lose on the first spin, win on the second spin, or you could lose on both spins. So the first thing we want to do is figure out the probabilities of this. So winning and winning, let's think. There's 6 numbers that you're betting on out of 38. And it's 2 times in a row. So using the multiplication rule, you can see that it's 6 out of 38 times 6 out of 38, which would be 6 divided by 38 times 6 divided by 38 is 0.0249. Actually, I'm not even going to do the reduced fraction. The numerator is 36, the denominator is 1444, and then we'll have approximately 0.0249. Let's just do that. Okay. Now we're going to do it again, but for winning and losing. Okay, so the chances you win on the first spin is 6 out of 38. Now the chances you lose. So when you bet on those 6 numbers, when your chip is sitting right here, there's 6 numbers that could win on, but there's 38 numbers total. That means that you would lose on 32 of them, because 32 and 6 makes 38. In other words, there's 6 winners and 32 losers. All right, 6 times 32. 6 times 32, there we go, is 192. So that gets us 192 as our numerator. If we divide that by 1444, we get 0.13296. So 1330, roughly, if you do 4 decimal places. All right. Now what about losing and winning? Well, it's the same thing, right? So losing is first, so it'd be 32 out of 38 first times 6 out of 38 second, but the probability is the same. And that's because these are independent. Then losing and losing would be 32 times 32. So you lose on the first bet, lose on the second bet, and 32 squared would be 1024. And if you divide that by 1444, you get 0.7091. So let's do this. 1024, this is 0.7091. Now if you did this correctly, these 4 numbers here should all add up to 1, right? So let's check it. So 0.0249 plus 0.1330 plus 0.13, forgot my decimal place there. Oh my goodness. I'm typing it correctly, but I typed too fast for the computer to register, so at least that's my story. And there we go, it's 1. Now, if it had been like 1.001 or something like that, we wouldn't have gotten all upset. That would have been a rounding error, but it should be right around 1. Okay, so now what's the probability that you would win on at least one spin? Okay, so winning on at least one spin, that's these 3 zones right here. So let me just highlight them in, well, you're winning, so let's make them green for money. So you could add up these 3 zones. So the probability of winning, let me type this up 1 second. Okay, so we want the probability of winning on at least one spin. That means we want the probability of win-win or win-lose or lose-win. Those 3 that we colored in green right here. Those 3. And of course it didn't say or, but of course it has to be because those are the 3 ways that are possible that you could win, and they can't all happen at the same time. They're disjoint, right? So you have to find the probability of win-win, which we already did. It's 36 out of 1444, plus the probability of win-lose. And there you have it, plus the probability of lose-win. Notice I didn't use the reduced fractions. This is why I didn't reduce them earlier, because I knew I needed to be able to add when they had the same denominators. Of course, you could use the decimals as well. I mean, if you want to be, have not as much fun with it. I mean, personally, I always think that the adding as fractions is fun because I'm nerdy. All right, so let's see here. 36 plus 192 plus 192 would make the numerator 420 out of 1444. And then if we divide that by 1444, we'll get 2909. And there we have it. So you have about a 29% chance of winning on at least one spin. Okay, but the problem said to find it 2 ways. So this is the long way, believe it or not. It's pretty easy, but that's only because this is a pretty small problem. So I don't know why that didn't come through, but there we have it. So this is way number 1, and that's the long way. All right, so now we want to do it again, but in a shorter way. And the key is what we found for the sum of the entire column. If you remember right up here, we found that the column added up to 1. So these 4 probabilities have to make 1. And then it's right here is the lose-lose. There's where your real ticket is, because there's only one combo that's a lose-lose. So what you could do is take your lose-lose and just subtract it from what you know the total must be. And of course the total of the column must be 1. It has to be. There, I got it in there. So let's see. What I'm saying is the probability of at least one something. What we're going to do is we're going to take 1 minus the probability of no wins. Okay? In other words, it's 1 minus the probability of lose-lose. Now, it might not seem simpler, but it actually is simpler. And I'll show you why in just a second. So 1 minus, and then if you remember, lose-lose had a numerator of 1024. So what we'll do is just take 1024 and take it away from 1. But if you remember, then all that means is that this number 1 becomes 1444 over itself. So 1444. So I'm going to take 1444 is my numerator and take away 1024 is my other numerator, 1000. There we go. And I get 420, which is what we just got right here. So the answer is the same. Now, you might be thinking, well, they seem like they have the same difficulty level. Not really. See, in the end, to find it this way over on the left, you needed to find 3 separate probabilities and add them up. Now, for something as simple as this, where there's only 3 probabilities, fine. But what if you were going to let it ride on 7 and 10 for 10 spins of the wheel? For 20 spins of the wheel? Then all of a sudden this other way doesn't look so great. Because for 20 spins of the wheel, you'd have to find 20 wins in a row, 19 wins in a row, but then 1 loss. 18 wins in a row, but then a win and then another loss. Or do you see what's going to happen? You would have tons and tons and tons and tons, hundreds actually, of different combinations to add up. Whereas the lose-lose, there's only one way ever to do that. Just lose, 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 lose all the way across. So for bigger problems, the second way is actually easier for messier, larger problems when you're rolling the dice multiple times. Or spinning the wheel in this case, multiple times. Speaking of 20 times in a row, let's use the same idea over here from the one on the right to find that. So we want to find the probability of winning on at least one spin. Which method should we use? And the answer is definitely method number 2. There, I wrote it up. To find this probability with the method on the right, you would only have to find one probability. That's the probability of lose, 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 lose 20 times, and then subtract that probability from 1. If you wanted to do the left-hand probability, which might at first seem easier, the thing about it is that it wouldn't be a table with 4 rows. It'd be a table, the way this worked was 2 to the 2. So for every option, there's 2 outcomes, win and lose. Remember the multiplication rule from a previous section. So you do 2, and then there's 2 spins, so 2 times 2 makes 4. If you were going to do 3 spins, there would be 8. So the table would be 8 long. If they were going to do 4 spins, it'd be 16. And you can see where I'm going with this. If it's 20 spins, that's 1,000,000. That's over 1,000,000 actually. And then you just take away the 1 spin. So you'd have to find roughly 2 to the 20 different probabilities, minus the 1 for the lose-lose, but still, it's a lot, right? That's how many probabilities you'd have to find, as opposed to just having to find one probability. One probability, might not be pretty, but you can do it. But 1,000,000 probabilities, that would not be good. And actually, that's such a key point. I'm actually going to highlight it. So method number 2, using the at least one rule, is a lot easier, especially for bigger problems. All right, let's move on to the next one, but I'm going to move on to it in the next video. So I think we'll stop right here, and I'll see you back here for the next problem.